Hello, welcome to today's webinar. Let's get started. So this is the second installment of a series of conversations about utilizing agents and improving agents in production. Today we're going to talk about RAG and retrieval in relation to agentic networks, and also get into some of the weeds to understand, how does retrieval work? How do you apply it? And why would you potentially use retrieval and RAG as part of agentics and how that might change? So my name is Matt Wyman. I'm co-founder and CEO of Acario. If you're unfamiliar with Acario, we're a developer tools company focused on helping people build just amazing products that involve AI and LLMs, all sorts of different cool products. And to that end, our hope here with these webinars in this series is to uh, communicate all sorts of interesting things that we're learning, but also to have a conversation. So as I'm going along, if you have questions, please do just drop them into the chat. And then afterwards, we'll hold a bit of a Q&A session. I'm happy to answer questions that might come up as we go through, or things that might take a little longer to discuss. All right, with all that, let's jump in. The agentic RAG. So the world of 2023 really exploded in the front of semantic search, and we started to see all these amazing use cases. It's not as though those use cases didn't exist before 23. We just saw a huge growth in them. And certainly now with agents coming to the fore, we're seeing even more. So what I've done here today is I've put forward, I built a small stack essentially utilizing Vercel's AI SDK. Now, I could just as easily have used AutoGen or Crew AI or Pydantic or another solution. In fact, the last webinar I used AutoGen, but I'm trying to keep it, mixing it up, trying to use different things. And then for retrieval, I'm using Pinecone. Once again, there are lots of other choices, whether it's Quadrant or ChromaDB or many others. PG Vectors, quite popular. Chose to use Pinecone for this, a quick example, using OpenAI, of course, Acario for evaluation and for the error discovery. And then can't do retrieval if you don't have content. So in terms of content, I went and pulled about 70 total documents, about 50 from our docs area, about 20 from blogs, to pull together and create a little bit of an agent experience. Normally, I would actually show you how I built it, and then at the end, I would show you the chatbot. But this time I'm going to do it the other way around because I want to kind of get in all of our heads. What is this thing that we're talking about? So just quickly, here is this little chatbot that I put together for the purpose of this webinar, no other purpose. And this has access to our docs and blogs. So I can say things like, using Acario, how do I run a retrieval evaluation? Let's see how it does. It runs a little slow because it's running on my local machine. So here we go. You can see, and you also notice that it's multimodal. Forgot to mention that. RAG's more than text these days. You got to be able to do more. So this one can handle much more than just text. We can also ask it relatively vague questions. How do I set up a golden set scenario? And we'll talk more about what these things are. But just wanted to give you a feel for this particular little chat bot and its access to data. I'll come back here in a moment. My poor little machine. There it goes. It's going through and it's giving us all sorts of information. It's giving us a little bit of code, both TypeScript and Python, and describing how to set up a golden set. Excellent. So that's the chatbot we're going to play with today. We'll tear it apart and we'll talk about how we built it, and we'll talk about some of the different issues it has, but also some of the benefits and really kind of amazing things that come with utilizing retrieval in this other format. If we take a step back, there are going to be a couple moments in this webinar where I need to take a step to the side so we can describe how the pieces work and then come back to the core. If we think about what I'll call traditional RAG or semantic search of 2023, it typically had three phases. There was an intent phase, there was a retrieval phase, and then obviously generation. The intent phase was all about trying to figure out whether the query that we were about to hit the vector database with is actually correctly phrased, whether we had all the right metadata associated to it, and making sure that it was a query that we could actually resolve. If I start asking about avocado smoothies, my RAG's not going to have very much to say about it because it really only knows about code and TypeScript and Python and how to run evaluations and build scenarios and do monitoring. So there was always this sense in what I'll call the standalone RAG to have these different phases. And in each phase, you of course need to go break apart the work that needs to be done. Retrieval, obviously, there's a lot there. We'll get into it, but it's the embeddings and finally generation. Once you get all your results back, knowing how to stitch those back together again into something useful to the user was this sort of necessary and very discrete step. Now, one thing that changes as we talk about retrieval and RAG in relation to agentics is quite often RAG assumed a vector database. But when we think about it in terms of agentics, it's really just any kind of search. The same mental model applies, the same types of measurements like consistency apply, regardless of whether you're going out and doing a web search, whether you're going to SQL, obviously hitting a vector database, or even calling an API. And in some cases, you can even think of certain tool calls like a math function as being very similar. Because a math function, you might give it an equation, you get back to fact. And during your generation, you want to make sure that you correctly reflect the fact, not some other made up number or made up information. So when we think about RAG and agents, we need to go beyond just vector search. However, that said, vector search works and semantic search is amazing for LLMs and they're amazing for chatbots. So we are going to focus on that as our use case today. But just about everything we're going to talk about, especially the evaluation pieces, which we'll get to later, almost all of those are directly transportable to these other use cases. So some of the mechanics will work differently, but actually not in as many ways as you might think. And we'll talk about that when we get to the tools. So because vector search is going to be the focus today, because it's so magical with chatbots and language models, I just want to take a brief 20,000-foot side journey on vectors and what that is, also to introduce some of the concepts which we'll be looking at when we think about evaluation. So first, we take, what is this thing? Vector search. Fundamentally, we're going to take a whole lot of content, typically documents, typically textual, but it could be visual and other pieces. We're going to break it up into chunks. We're then going to run embeddings, which is basically creating vectors of numbers that represent those particular chunks. And then we're going to embed them into a search space, essentially like a topology. And we're going to go figure out whether the next question we ask matches some form, some set of those chunks. So if you haven't been exposed to this before, just really briefly here, imagine this is your vector space and all these little squares that are sitting and floating on the page are each, elements of these numeric arrays that are being overlaid to create this topology that you're going to search. Amongst those might be a set that you're interested in. So let's say we're asking a question. We're asking a question about when water might freeze. Well, we're going to take that question and we're going to convert it into a numeric array, an embedding. And then we're going to take this embedding that represents our query and we're going to see what it can match on the other side inside of the vector database. In this particular case, turns out there are two items which match pretty closely. And the first one is an answer that water freezes at 0 degrees, and the second is that water freezes at 32 degrees Fahrenheit. Well, Celsius versus Fahrenheit, these are both legitimate answers. They're both very close. And the reason I'm showing you this is actually to introduce two concepts. Well, three, embedding, but that's sort of goes without saying. But the two concepts are the k-value and the retrieval score. So k-value is this idea that we're going to control how many things we want to get back, but we're always going to get that many back. So if we say k equal to 2, then we'll get 2 back. If I'd said k equals to 5, then I will get 3 additional answers here. Maybe Kelvin, maybe what happens at water freezing at altitude. Who knows what the other 3 items might be, but they would be 3 additional items that are relevant to this particular question that we're asking. This is important to understand as we're getting to the agent network and we start to think about things like re-ranking, making sure that the agent network has the appropriate data to write the generation back to the user also depends on, well, limiting or expanding, as the case may need to be, how many results we pull back from the vector database. And then the other one is a semantic score, this scoring algorithm to determine how close was this answer to what you expected to be the real answer. And that's going to be very important when we get into evaluation. And you'll see how we use that as well. For me, if I think abstractly about this whole thing, I'm a big hiker, I mountain bike and hike and love to get out in the world, but I often forget the names of trails. And so vector search for me is a lot like the ability to describe, in this case, a hiking trail, and having the topology come back and say, look, this is exactly the trail that you're talking about, or it's probably one of these 2 or 3 trails. It's part of what makes it so amazing. Instead of searching based on a table and a row and a column, you're able to have this much more open-ended, more user-driven, description-oriented query that can come back with a variety of answers. That's in the chatbot case. Now, there are many other cases, product catalogs and other worlds, and other types of data sets. Every search and RAG is based on the actual data set that's being returned, but in all cases, you get this benefit of this stochastic or statistical model that's able to return more than one result based on the sort of distance from your original question. Okay, back to the RAG. So now we've understood a little bit about retrieval. Remember, there's intent, retrieval, and generation. So let's dig in. What did that sort of standard RAG look like? This is, and by the way, this is a completely valid way to build, but it's starting to shift as as we're having conversations with people and hearing what they're doing. The sort of standard RAG has these 3 very discrete components hardwired to each other. There's a very discrete intent step where you take in the question, rewrite it, add metadata, and then you call your vector store. And the retrieval step not only goes and pulls back based on some sort of K value, pulls back information, and pulls back those chunks, which you can see in this bottom right, but typically often goes through and re-ranks them, figures out which ones are actually more relevant, which ones are more pertinent. There are a variety of re-ranking algorithms, all very much based on the content that you've embedded. But the key concept is that there is some sort of manipulation of the results, and then eventually those are handed back to a very discrete generation step, and some sort of answers provided back to the user. These 3 steps, baked in this very somewhat rigid manner, can be incredibly performant and useful. But one of the reasons to start to step beyond it towards agents is you start to get a lot of benefits by loosening some of these different touch points. In fact, I would argue that the 2 agents and retrieval obviously are a very natural fit. One of the reasons we're seeing so many chatbots and chat interfaces using vector search and semantic search is because they work so well together. In the case of an agent network, when you start to bring in retrieval, each one of these steps changes in some subtle ways. So let's take intent. First thing is you often don't need to have an intent step at all. If you tuck the retrieval inside of a tool, then access to retrieval will include summarization. It will include some sort of rewriting of that initial request, but based on the context of the entire history of conversation that has come before that moment in time, or based on the rest of what's in the particular context space. For example, we asked a question of the little chatbot I showed earlier about how to set up a retrieval, and it gave us back both Python and TypeScript. Had I started the conversation with, I'm only interested in TypeScript, it would not have returned any Python code. And in fact, it would have biased for portions of our SDK docs that are in TypeScript. Might have given me back some slightly different answers and maybe some slightly different examples. And that's because of a memory, if you will, in quotes memory, but context history that it's able to pull into this step of rewriting that original intent. There's also a nice benefit in being able to expand, and we'll talk about that when we get into the architecture. But quite often, if they're rigid, then the number of data stores that you can talk to, it has to be well known. And if you move into an agent network, you can sort of dynamically provide those or remove them based on circumstance, essentially based on the plan. The retrieval task between the 2 doesn't change a huge amount. That task stays relatively similar. Again, wrapping it in a function seems to be a really good way to go, because of the flexibility that it provides you. But the real key here is that the amount of information you can sort of carry with increases, that metadata, if you will, increases, which can make the search much more accurate and provide you a lot more, many more mechanisms, if you will, to get the re-ranking correct on the other side when you're trying to figure out which chunks are actually the most relevant chunks to return back to the user. And then last but not least, generation. So this is wild, frankly, this is wildly different between the two. So once you have an agent network, you know all sorts of things about voice, you know how tone, you know more about the user in terms of persona. And so you can actually get the same chunks back, but give a very different answer based on that information, who you're actually talking to, what they want to hear, what's the style of communication that you're hearing on the other side. So this part actually does change quite radically, between the two systems. And it's really a very fundamental change just because of the context in which it's being done. The other thing I'd observe is that LLMs seem to have a dialect called Markdown. It's just so prevalent in the web that most of the inference, most of the large language models are extremely good with Markdown. And so one of the things that's really beneficial if you're having the sort of chat-based conversation is to be able to leverage Markdown as part of both the processing, which we'll see, as well as the response that comes back to the user. And that knowledge of the method of response is important in your generation. Now, it's also possible that the RAG you're building is completely outside of a user experience, and you still might want to use an agentic network. And those cases, quite often we see that with product catalogs, and we see that with contract catalogs and legal catalogs, where people are, building agents to answer very complex questions that involve multiple documents, but still has a similar character to it in the types of the prompt engineering, if you will, around the generation. Okay, so they're different. Great. But what does that look like? Well, if you're starting to think about retrieval inside of an agent network, there are a variety of different ways to architect it. Now, in the last webinar, I talked about some of the different agent patterns. We talked about tool calling, planning, multi-agent, swarm. We talked about others. All of those can be used, and you can tuck retrieval into different portions of your architecture. For example, you could have an agent that represents the retrieval step, and this agent participates when the right conditions exist. That would be more the swarm model. However, the pattern that we're now seeing quite a lot, and I did today, was again the tool calling, the function call, where each of the different potential destinations for search is represented in the tool space as its own discrete function call. This has a lot of benefits. For one, you can separate. Now, I happen to have mixed my blogs and docs into a single vector space, but I could easily have separated them into a blog call and a docs call and let the agents figure out which one to use and when. But I also could have introduced other types of search. And you actually will see agent networks emit, when you use this method, you'll see them emit multiple searches across different functions at the same time, gathering a much broader set of information. And that creates a richer set of data that comes back and actually provides you more clues and more ability to be highly precise and targeted in your generation step when you're giving back the answer to the user. So although in some respects it's simpler just to put it in as a function call, what you see of the network itself is it actually covers a lot of those intent and generation steps just very natively. So now you can think primarily about the retrieval, and you can actually change how you think about identifying intent and identifying generation, because that's something that the agent network will need to understand, regardless of whether this particular interaction requires a search. In the case of the little agent that I showed at the top of the presentation, these are the different nodes that I had in place. I have a planning node that actually dynamically generates a plan for the agent to follow, and then have a CX agent, a customer experience agent, that has that conversation back and forth with the user. And then I had a set of tools available were the docs and blogs. And actually, I didn't put one in here, which is the math tool. I actually do have a math tool in there as well. It's able to go back and forth and utilize those as appropriate. So all the different pieces of the RAG are handled in this network and done so correctly and effectively, even though it's a much more simplified network, if you will. In fact, can do many more things as well. All right, so let's just take a moment and take it apart. Let's get to the more the core of this thing. Starting off, it's been my experience that if you're going to build an Agentics, you need to put in some sort of observability layer. At Acario, we think of that in terms of error discovery. We think it's more than just observability, but you need something to show you how the agents are talking to each other. In our case, it's as simple as pointing to a proxy and providing an API key. We also have open telemetry, but there are lots of ways to do this, but it's absolutely mandatory that you're able to see how the agents are conversing and see where the retrieval is being called and when it's not being called and dig into it. Actually, I'm just going to take a brief step. Let's see here. Let me go over here and just show you some of what that looks like. If we take a look at this trace, you can see this was the one we just, let's make sure. Yep, that's the one using Cario. How do I run a retrieval evaluation? This is the one we just used at the top of the conversation. We can see already the tools that are available to it. There was that math function. Here was that retrieval function. You can see it's called answer questions about Acario. You can see it takes in a session ID and a question. And if we dig in a little bit more, here was the question we asked. How do I run retrieval and evaluation? And you can notice here, it's actually already been rewritten. It was restructured just a little bit to put the Acario at the end, because that was a better phrasing given the particular search we're going to run. And then we can see all the different tools that came back, and we can see that it gave us back an answer. We'll come back and look at this in a moment, but you can also see that occasionally it makes mistakes, and we can trap that without just dynamically by looking at the information. So in this case, there was a context consistency issue where the user's question was not actually addressed in that particular search, in that particular conversation. So it's absolutely critical that you have some sort of mechanism in place to give you visibility into how those agents are talking back and forth, because there's really almost no other way to do it. You really have to work at that level of real-time evaluation. But here's the real core of how to make it work. It's the data pipeline, your approach to embeddings, then the evaluation loop of the two to make sure you get it right. And then, as we talked about, the agentic piece, which really we just covered. So let's start with the data pipeline. In the case of this particular chatbot, when I grabbed all the docs and blogs, the very first thing I did is I converted them all to Markdown. Did that for a number of reasons. One, as I mentioned, it's become like the native dialect of language models, but it's also because it allows us to embed a slight more information, and it allows us to use information from the documents themselves as part of the clues for chunking and for some of the other steps. So for example, even though the blogs are all in HTML, when I pulled them down and converted them to Markdown, I use a single hash for title, double hash for headings, triple hash for subheadings. All the code was correctly identified, including whether it was Python or TypeScript or JSON, etc. And all those little semantic clues wind up being very helpful to the query later. So if I'm asking for, Python for creating an Acario scenario, it will be able to go retrieve that chunk, and it's going to be able to retrieve the chunk because that code snippet that shows how to do that task includes that information about Python. I also, as part of this step, downloaded all the images, and I did a little rewriting in the Markdown so that all the images would be available. You might remember that this was multimodal, and that was how I solved the multimodal problem by pulling in the images and then also rewriting the Markdown so they would be available. So whenever they showed up in the Markdown, it knew to process them and provide them as image links that would then be visible on the other side. And of course, I did a little bit more with paths to make sure all the paths were clickable. Last but not least, I knew that we would have to run this many times, and if I were working in a larger group, it's certainly possible that as the data changes and as the code changes, I'm going to want to rerun this type of data pipeline. So I built everything in scripts that I could attach to CI. Acario has a facility for that. I'm sure others do as well. But the important bit is that it's all something that you can run from scratch at any time that you need to. You don't have to go to a notebook and push a bunch of buttons. That's wonderful if you're alone, but if you're in a group, that can be error prone and a little difficult to repeat. The next step, this one was actually the one where I well, we'll talk about it in detail here, but I could have gone much further. So chunking is a really big question. Like, how do you want to chunk the data? How do you want to go through and figure out whether or not it's working, and figure out how big are the pieces you want to return? Now, remember that K value concept. We're always going to return more than one element in the retrieval, whether it's 2 or 5 or 10. But the more we return, the more tokens we use, the more we return, the slower the final generation is going to be. And the more we're essentially, I'll use the word polluting the context with additional information, some of which may not be relevant. So figuring out our chunking strategy is really critical. In this particular case, I tried a couple variations. I tried chunking by 50 lines. I tried chunking by 100 lines. I also played a little bit with those markdown headers to make sure I had full concepts within the chunk. So whenever there was a new subhead, I went ahead and just started a new chunk. Ultimately, what this does, along with the overlap, is it gives me the chance to see how these things fit together. This is the place where you have the largest point of leverage to improve quality coming back. And if you're even remotely thinking about fine tuning, this is the place to start. So you can do a lot without fine tuning, but when it comes to embedding models and figuring out how to embed, this is the place where you can do the most. And there's a wonderful set of blogs on our website from my co-founder Boris, talking about really detailed strategies around fine tuning. Needless to say, you can use our synthetic data to go take failure cases and expand them so as to highlight what you don't want the embedding model to do, or take successful cases and expand those to really highlight the types of behaviors you want the embedding model to follow to return the most accurate information possible here. And a simple example of this, we have a customer in the automotive space, so I like to use this example where air and oxygen don't mean the same thing depending on what part of the car you're actually looking at. One of them is in the engine compartment, the other one is in the passenger cabin, and you really don't want to confuse them. And fine tuning is one of the better ways to make sure that normally similar concepts get pulled apart. So they're statistically further apart, and therefore answers that are addressing one or the other are more often returned correctly. So those first two steps are super critical. So really the next one is to use evaluation to make sure that you're seeing what you want to see. Now, in the case of our blog, I only spent a little bit of time doing evaluation, but I'll show you just for a moment what that looks like. Um, but this is really the core. If you're going to build some sort of retrieval mechanism into your agents, this is a critical moment of what's my embedding strategy, what's my chunking strategy, and then going through and testing it. In fact, before I even walk into this, if you're going to do any testing, you have to start with some sort of golden set. So let me just quickly show you what that might look like. So here, I'll just grab a subset of JSON. So these are example chunks and sort of the ID for that chunk. And what I'm going to do here quickly is I'm going to go through and just generate a set of questions that should go directly from the chunk on the left to that expected result on the right. And then once I have these, so now we see a series of questions. Each of these questions is relevant to that chunk that was provided. Once I have these chunks, this golden set that should work because we generated it from the core data, then I can come across to retrieval and take a look at how well it actually performed. So here I'm looking at one particular view, the a sparse embedding. And I can see that, in fact, I have quite a few that didn't work at all. They didn't find the right element. I can look into them. I can see that they found many elements, but none of which were the correct one. So, of course, I went and ran it again. So let's see here. Let's compare to another model. Let's do the, sorry, I'm going to move Windows out of the way. Yeah, to the dense. And we can actually see that when I changed up the methodology, I think I was over here. Yep. When I changed up the methodology from these really small chunks to these much bigger chunks, and changed up how I was dividing up the different concepts, I actually got a hit on k=1. In other words, the very first response back was actually the one we were looking for. Here it is here. And you can see on the other side, the very first response was much shorter, but also not as relevant to this particular question. So there's a lot here. There's a lot to dig into. It's all very much based on the type of content that you're embedding and the kind of app that you're building. But either way, this is a critical part of the larger loop, going from figuring out your embeddings, figuring out how to do your embeddings, and then going through that evaluation step. So, and I skipped a little bit here, skipped forward, but once you do your embeddings, you do your storage, you do your evaluation. Oh, I want to get, there it is. So this loop here is absolutely central and critical to making sure the actual retrieval step works the way you want it to. And many of the pieces are a little more on the mechanical side. So this one's absolutely critical with the chunking. Embedding is all about picking the right model for your embedding, and this is where the fine tuning really is critical. And then storage is a little more mechanical. You can use Pinecone, Quadrant, Chroma, whatever you choose, and it works well. And then, of course, finally, you do that evaluation that I just showed you and just jumped into a little prematurely. And then last but not least is the agentics, tying it all together. And this is all, of course, based on prompt and the prompt engineering of the different agents, making sure they can pull together the answers and know how to deal with ranking and re-ranking. So at this point, we've now built an app. The app does more or less what we want it to do. We saw in that evaluation that there were quite a few areas where it was not working incredibly well, which could easily be solved with just a few hours more work, by playing with different embeddings, playing with fine tuning, and going through that life cycle loop a few more times. But the real key is that those are all the pieces, and those are the critical places where you would want to leverage, uh, the retrieval to try to get it to work and go from a more traditional RAG to a more agentic RAG. So key takeaways. There are a lot of patterns for how to approach uh, building retrieval into your agents. Um, you can look at the webinar from the last webinar to look at the agent patterns, but even here you can see whether it's tool-based or agent-based or whether it's standalone. You've got a variety of choices there. Tool calling seeming to be the one that currently is getting the most traction. The evaluation needs to be both what we call offline and online. So I showed you offline there at the end where you were seeing two different retrievals and seeing how different questions were scoring from your golden set. But we also showed you the online evaluation at the beginning, where simply as information was flowing through, we were able to call out which ones had consistency issues, which ones had function call issues. We were able to highlight where your problems might be. In fact, there's a lot of connective tissue between the two. Uh, we didn't get into the weeds of this, but facts can be very tricky. Things that look like it can be right answers actually can turn out to be wrong answers. And it turns out that model judges looking at completions as they pass through the system are incredibly good at calling out when a completion doesn't actually include or perfectly answer the user's question or include all the facts or appropriate facts from the request. If you're quote unquote vibe checking a system, it's actually very hard to see some of those. It's easy to see a blatant hallucination, again, talking about avocado smoothies, but it's hard to see the subtle issues. And quite often, having checks in place, these model judges in place, can call out, can identify those errors very discreetly, so you can address them when it's difficult to see them without that light shining on them. And last but not least, I think a lot of people have been vibe checking and have just been building, 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 trying to go as fast as they can. But we're at a phase now as people move to production where the metrics become much more important. And in order to measure those metrics, as developers and builders, of course, we're accustomed to looking at all the weeds, but quite often we need to bring with us the subject matter experts who actually do understand all the little nuances and details and can help us identify where there are issues and where we should be fine tuning, where we should be changing the chunking, where we should be maybe pulling some documents out or combining them as part of our overall retrieval project. So I like to end with this because I think there's a new way of working given the non-deterministic world that we're in. And in this new world, we have to run experiments. We got to try things. And so a lot of what I'm telling you about are from experiments that we're seeing our customers do and experiments that we've done, trying different ways of solving RAG and solving retrieval. So think like a scientist, build like a developer, get those unit tests in there, get those metrics in there, use observability, make sure you've got things in CI, and then of course feedback like an SME. I think at the end of the day, only the subject matter experts can say whether or not a non-deterministic system is doing what they want. So we need to pull them into the conversation more than we may have done so in the past. We have reached the end of the primary material. I'm happy to answer questions across retrieval agents as far and wide as it makes sense. So I'll give everyone a moment here to drop some things into the chat. There's a question about uh, which vector database I used Pinecone. So Pinecone has a nice open tier. There are lots of other choices, but I really like the ease of hooking them up, and they made it very simple for me to use. I chose in this presentation to use TypeScript as opposed to Python. So they had a nice TypeScript SDK for me to use. Anything else? All right. Well, you know where to find us, Aquario.com. Feel free to reach out and ask questions. We're always happy to answer them. We're always happy to hear about what people are doing. I invite you to come and give us a try when you're building your next agent and next retrieval system. And thank you for your time today. All right. Bye-bye.